Creatine has long been associated with athletic performance and muscle building, but functional medicine is beginning to reframe this simple molecule as far more than a fitness supplement. In the context of systems biology and whole body health, creatine emerges as a deeply strategic tool for enhancing energy metabolism, buffering stress, supporting cognitive clarity, and even slowing certain aspects of biological aging. Unlike stimulants that push the body harder or faster, creatine works at the cellular level, helping the body regenerate energy naturally, especially in tissues that demand high amounts of ADP, such as muscle, brain, heart, and immune cells. At the center of this expanded understanding is mitochondrial health. Mitochondria are the energy factories of our cells, and their dysfunction is a common thread running through many chronic illnesses, from neurodegeneration and autoimmune disease to metabolic syndrome and chronic fatigue. Creatine supports mitochondrial function not by replacing lost energy, but by improving the efficiency of ADP recycling. Through the phosphocreatine system, creatine donates phosphate groups to rapidly regenerate ADP from ADP, especially during times of peak demand or energetic crisis. This buffering effect becomes even more important with age, as mitochondrial capacity declines and energy deficits accumulate in both muscle and nervous tissue. In this light, creatine becomes not just a fuel reserve, but a resilience molecule, preserving cellular output when systems are under stress. There's also growing evidence that creatine impacts inflammation and oxidative stress, two drivers of accelerated aging and chronic disease. While creatine is not a classical antioxidant like vitamin C or glutathione, it may help indirectly reduce oxidative burden by sparing mitochondrial overwork and improving cellular energy efficiency. In immune cells, for example, creatine appears to enhance the energy supply needed for appropriate immune responses while limiting excessive inflammatory signaling. Studies in models of neuroinflammation and muscular dystrophy show that creatine supplementation can reduce markers of tissue damage and improve functional outcomes, suggesting that creatine may help maintain homeostasis in inflammatory or degenerative conditions. This is particularly relevant in the brain, where energy deficits are tightly linked to mood disorders, cognitive decline, and neurodegeneration. Creatine is naturally concentrated in areas of high neural activity and is increasingly being studied for its effects on mental health. In functional medicine, where the goal is often to support long-term brain resilience rather than just manage symptoms, creatine becomes a valuable adjunct. It has been shown to improve mental fatigue in sleep-deprived individuals, support working memory under cognitive stress, and may offer neuroprotective benefits in conditions like Parkinson's or early Alzheimer's. Some early studies also suggest that creatine supplementation can reduce depressive symptoms, particularly in women or individuals with treatment-resistant depression, perhaps through enhanced ADP availability in serotonin-producing brain regions. Beyond physical and cognitive energy, creatine plays a supporting role in quality-of-life markers that matter deeply to functional medicine: muscle integrity, metabolic flexibility, bone strength, and emotional resilience. Aging adults who supplement with creatine consistently show improved grip strength, better mobility, reduced frailty risk, and even enhanced reaction time. These are not trivial outcomes. They translate into independence, reduced fall risk, and higher engagement in life. In this way, creatine becomes a tool not just for performance, but for vitality. It's also surprisingly well aligned with the nutritional philosophy of functional medicine. Individuals following plant-based or low-protein diets, often for detoxification or inflammation management, may inadvertently reduce their intake of creatine, since it is found almost exclusively in animal products like red meat and fish. For these patients, supplementation can correct a subtle but important deficiency that may otherwise impair physical and cognitive recovery. Similarly, patients recovering from illness, surgery, or burnout, whose mitochondrial reserves are depleted, may benefit from creatine as a safe and non-stimulant means of restoring cellular function. Still, creatine is not a cure-all. Like any intervention in functional medicine, it works best when integrated into a broader plan that includes whole food nutrition, circadian regulation, stress management, and movement. Its safety profile is excellent, with decades of research showing no adverse kidney or liver effects in healthy individuals. But it is not magic. It simply makes energy production more efficient, especially when cells are stressed or aging. What it offers is not an artificial high, but a more stable baseline from which healing, adaptation, and growth can occur. In conclusion, Functional medicine practitioners are beginning to see creatine not merely as a supplement for athletes, but as a foundational molecule that supports human energy systems at the most fundamental level. Its ability to bolster mitochondrial output, reduce inflammation, enhance brain function, and preserve lean body mass makes it a valuable ally in the pursuit of longevity and resilience. For patients seeking more energy, sharper cognition, and slower aging, not through overstimulation but through cellular support, creatine may be the quiet powerhouse that finally gets recognized for the broader health tool it truly is.